me try again. Okay, great. Let me know if that happens again, and I'm happy to unshare and try again.
It looked like it was like trying to readjust or something, like the size.
Okay.
So I'm not sure.
Okay.
We'll figure it out.
Yeah. That sounds great.
Also turn this one on YouTube. Hello everyone. For those of you on YouTube, can you give me a thumbs up? Or YouTube cannot give a thumbs up. You cannot send a chat in on YouTube. See if you can hear me. And let me see here. Oh, it's from everywhere around the US. That's great. So we'll start maybe in 2 minutes. We will give some time for people to join, and then we can get started. Yeah. Okay, great. There are some from YouTube. Oh, even from Mexico. Welcome. Some from other country, from Turkey, from Cambodia. So it looks like a lot of people are interested in open science. That's great to hear. And let me send the link in the chat. So okay, we will start in 1 minute. All right, it's about time. So let's get started. Welcome everyone to the second Open Science workshop on open data. So the Open Science workshop and symposium is sponsored by the University of Tennessee College of Arts and Sciences. We also collaborate with the UTK libraries, basically to give a series workshop to introduce you to open science. We cover a variety of topics from open code, open data, open access funding, open result, and also open publishing. So we meet Monday Eastern time, 10 a.m. Eastern time for the next couple of weeks. You're welcome to join. You can check out the website. I send the link in the chat. You can also just type the URL openscience.gshub.org. You should be able to access the website. On the left side here, you can also find some of the open access courses that I'm teaching, books, and also open source projects. So throughout the workshop series, I will use some of those for demo, just to show you how I'm practicing open science and how you can also benefit from some of the open source tools or open data platform to make your resource more accessible to the public. And so for today, we're gonna focus on open data. We have two guest speakers from UTK libraries, Brian Doss and also Jordan Kaufman, and they will be talking about open data and some of the resources provided by the UTK libraries. And then I will cover some of the practical tools and also there are platforms that you can share your data. For example, using GitHub, Hugging Face, or Zenodo, some of those tools. And I will showcase some practical example how we can put the data on the internet and then how we can stream the data on demand so that you can do some research and makes your resource more accessible and also more reproducible. And today is just covering the data, and we in the next workshop we cover how you can use some of the open access funding to do journal publications and how do you share the result. Also how you can write, for example, tutorials, even write a book using open source tools and also publish for free online. And so next I want to hand over to Brian for introducing open data and also the UTK libraries resources. Brian, it's all yours.
All right, great, excellent.
You can, let me stop the sharing.
All right, I think I just took over your share. Can you see my screen?
Yes.
I can see it. Yep.
Okay, excellent. All right, well, thank you for that introduction. I'm just happy that everybody is here, and I commend everybody that is Zooming from where it's very early or very late. But anyway, we're very lucky to be a part of this symposium, and we really appreciate Dr. Wu for putting this together. Essentially, I'm going to start off by giving an overview of who we are at UT Libraries and the research data services that we support. Then I'm going to hand it off to Jordan, who's going to talk about just some of the basics of why open data is important. And then I'll get into specifics about how we can help you share and preserve your data, and maybe a few minutes for questions at the end, depending on what we have time for. So usually the organization within the library is really not that important or pertinent to library users, but we do have a department that I lead called Data and Digital Scholarship within UT Libraries. We have me, I head up this group. We also have a data science librarian, a research data librarian, Jordan, who's here with me today, a digital scholarship librarian, our engineering subject specialist, and our GIS specialist, Eric Arnold. This is kind of a brief overview of a lot of the things that we cover, kind of data literacy and ethics. We do provide that general traditional library support for engineering and research and collections. But essentially, these three areas are the ones that really touch on the open data and open science. We can we help researchers, students find and evaluate data sets and sources that are out there. We also help support best practices in data management and sharing, and then just kind of navigating open research in general, because we partner a lot with our scholarly communication librarian and other people in the libraries that deal with open research. But I'll be touching on later in this presentation specifics of the resources and services that we provide to support this. But I do like to bring up the data lifecycle in general. This is a very basic, you can have a data lifecycle representation that can be very complicated, that shows all of the really intense steps that can go through the data lifecycle. But this simple representation of data lifecycle helps me understand maybe where different researchers and people may be in the process. And I like to think of the libraries as kind of the data concierge, that even if we're not going to be helping you as much with the processing or the analysis, I and my team, we're familiar with our data partners across campus and are able to kind of connect you with those resources and services. So I always really like to point out that you may be in a different part of the data lifecycle and need different things, but that there are specialists like us in the library and Dr. Wu that can help you navigate the different parts of the data lifecycle. And with that, I'm going to turn it over to Jordan, who's going to talk about open data and why open data is important.
Thanks, Brianne. Can you go to the next slide? All right, so I just want to quickly touch on what is open data. Next slide, please. I really like this quote from the Open Data Institute. So simply put, open data is data that is freely available for everyone to access, use, and share. So we don't want to overcomplicate it. It's as simple as that it's available for everybody. Next slide. So what makes data open? Dr. Wu talked about accessibility. You're going to hear that word a lot today. So open data is accessible and has access to it. So that means it's easily available to everybody. It's in a convenient form, and it's also available in its entirety. Open data is reusable and redistributable. People are permitted to reuse and redistribute in whichever way they want to. It's also available to all, which means it's equally available to groups in the private sector, to individuals. That could be your mom or dad or your grandma. It's available to researchers, like many of you here, and to public organizations. You're also able to reuse and redistribute it for whatever purposes you want. Next slide. So I want to talk about what else is, what open data is, and it is fair. So the FAIR principles mean it's findable. Your data is easy to find, the data and the metadata for both humans and computers. Again, accessible, our big buzzword for today. It should be retrievable by its identifier using standard or open protocol. It's interoperable, which means it should integrate with different systems, data, applications, and workflows. And it's interpretable by various sources. So we're trying not to use proprietary tools. It's also reusable. So we optimize the reuse of data. In order to do this, it should be well documented. And Brianne's going to talk about one of the tools that we can use to help do that. So while FAIR focuses on the characteristics of data, there's also the CARE principles. And those were created by Indigenous people to encourage open and other data movements to consider people and purpose in their advocacy and pursuits. So we're being equity minded with that. So we have the FAIR principles and the CARE principles. Next slide, please. Okay, so we've talked about what open data is. Now we want to talk about why open data. And open data is not just something we do for the sake of open data. There are real benefits. One of the benefits, it makes it accessible. It increases the number of data sets available for others to analyze and draw conclusions, which can lead to community engagement, effectiveness, and progress. It also increases transparency. It helps citizens and consumers better understand different entities and become more informed. And that also increases engagement and trust with consumers and those different entities. Innovation, it's offered without that monetary barrier, which can fuel for new solutions and it can help address problems. And then management. It helps integrate between systems, break down silos, which can improve efficiency. So for example, one data set may address multiple things, but if it's being pulled from different areas, it's repetitive, so it can help break down that barrier. Next slide, please. So while we strongly believe in open data and what it means, we'd be remiss if we didn't mention that there are arguments and some fear around open data, and that is completely valid. So some of those fears include incorrect use of data. So questions might be, what if my collection methods and metadata are misunderstood? Fear around privacy and consent. Some data are proprietary in nature and have sensitive information. Reputation, someone might be concerned that their data is going to be used against them by finding errors, and someone might claim credit for their work. And understanding, people may think, you know, their data is too complicated to understand, or no one needs to understand their data. Next slide, please. And I just want to give some real world examples of open data that we see every day and how it's really benefited society. Next slide. If you've heard of OpenStreetMap, this is an open data volunteer-driven global mapping platform, and it powers map data for websites and humanitarian crisis relief around the world. NYC Open Data is a repository for data sets created by various city offices and agencies. So people can look up zoning and building data, and there's also research on such things as school bullying that the public can access. There's also food trade menu, which helps small businesses, restaurants and caterers to create customer menus with most up-to-date.
Hey, Jordan, can you pause for just a second? I just need to stop my share and reshare.
Yeah, sorry.
Yeah, it looks like the screen is flickering, so maybe you can stop share and then reshare again. I'm not sure why. Is it kind of Zoom problem?
Yeah,
maybe?
I don't know what is up with my Zoom today. I apologize. I appreciate it.
Okay, it's fine now. It looks okay now.
Oh, we lost it. Oh, okay, it's back.
Are we there? All right.
Yeah. Yeah, so food trade menu, again, being able to comply with those food standards to help with allergens. And then lastly, I'm on Zillow all the time. I bought a house recently and I was using Zillow. So Zillow uses open data to provide users buying, selling, renting, and financing. And this information is all accessible on the link below, data.europa.eu, and it shows the different case uses where you can look at different ways open data is being used. And I thought that was a really great website. So I think I'm going to turn it back over to Brianne.
Great, thank you. And please let me know if the display is flickering again. So thank you, Jordan, for those examples. And I'm just going to call it like the specific support that we have for open data, and specifically those concerns with sharing your open data, talking with the librarian and navigating the many different archives and venues and other things that are and tools that are out there is something that the libraries can do. So I'm going to go over kind of these three main areas and kind of show you our research guide and other things and tools that we have. One of the tools that I really appreciate as a researcher that applies for grant funding, as well as a data librarian that helps other people apply for grant funding, is the DMP tool. So it's called Data Management Plan tool. And what I like about it is that it allows you to pick what funding agency you're applying for, and it will give you their data management planning guidelines and ask you questions that you just have to fill out to answer. That helps you create your data management plan. And UT Libraries has a membership with the DMP tool, which means that you can submit your data management plan to the library for reviews and comments. And this is a really helpful way, instead of digging through the funding agency's documentation yourself, it's a way to kind of simplify it and streamline it. And so I highly recommend, if you are interested in the best practices of data management planning, or you simply just need a data management plan to make sure that you're within your funder requirements, using the DMP tool, working with UT libraries to review your data management plan, if you feel like you need that support. And that's another thing, is that we do help people navigate different funding agencies' requirements, whether it's government or other, that there can be like, how do I need to plan to share my data? How do I need to work through this and have a plan from the beginning so that my data is accessible and findable, and using those FAIR and CARE principles. Also, depending on what your funder's requirements are, what your goals are with your research data, the formats of your research data, we can also help you navigate where to plan to share your data from the beginning, from when you're collecting your data, managing your data, because there are many options, especially in the social sciences. There are hundreds of different archives and places that you can put your data, along with the more open places like GitHub and Zenodo. So we can help you identify what your goals of your research and sharing and preserving your data may be, and where you should end up sharing those. Along with that, we do help you identify the secondary data, this open data, in your different fields and where it can be found. I spend a lot of my time navigating different disciplines and their different data archives, and maybe the different resources that they use, either from government websites or other funding agencies, that if you are doing research, there may be data that can complement your research, or even replace your own primary data collection. And I find that that can be really helpful to know what is out there, because again, there's a lot out there across the social sciences. We also help people evaluate the data that they find, and the secondary data, and also being able how to ethically cite and use secondary data, and where it's appropriate and where it's not. And that's something that we work together with OIT with, and this is a lot of the work that our data science librarian does. We also do encourage the sharing and preserving of research data. If we did not rely on researchers to plan, to share, and preserve their data, then that kind of loop of that data life cycle doesn't work. So we need to be able to encourage and support researchers to share their data. And so UT Libraries, we have this fund called the Data Archiving and Sharing Support Fund. And it is essentially a fund that funds a deposit in Dryad, which is a multidisciplinary data archive. And the reason why we support putting data in Dryad where it's available is because of how open Dryad is. It's indexed by Zenodo and by Google dataset search. And the reason why they charge a archiving fee is because they provide curation services. And I think that's really important, because if we're expecting researchers to share their research data, it is unfair to be like, okay, also be an expert in how to make your data completely discoverable, and the kind of metadata and descriptions of your data that would be meaningful to make your data discoverable. And so right now, where appropriate, we are asking researchers that if they are interested in sharing their data, to apply for this fund. It is a really short application form, just like 4 questions, and then we'll reach out and help you get connected with depositing your data in Dryad. And if there is another place that you're interested in depositing your data, that is something that you can reach out to us about, and that we can help you navigate. But I wanted to make sure to showcase the Data Archiving and Sharing Support Fund. We also just have a general research guide for research data services and what we support. I kind of have put them in these 4 big buckets of our research data services, of our data management planning, how to get data, working with data, and sharing and preserving your data. So I recommend, I can drop this link in the chat. But there's a lot of helpful information that we link to the DMP tool. We talk about best practices, give you different insight, and then also ways that you can share and preserve your data, whether Dryad looks like it's going to be a good fit for you, or if you need to get in contact with us and we can help you find other resources and services. But you can click through here and see we have we subscribe to many data archives and other services, and we can help you find that. We have a list of the different APIs that UT Libraries has access to have that more machine automatic pull of data. And yeah, also our tools for how to work with your data once you have it. Another thing I wanted to bring to everyone's attention, because there has been some concern about data that has been open for a while, that has been collected by and archived by governments, specifically our government here in the US, and what happens if maybe that primary source of data has gone away. Well, in January, a group of librarians and archivists and other data enthusiasts started this data rescue project of ways that we could take the data that had been publicly available and archive it somewhere so that it can continue to be found and used. I've worked a lot with some of the census data that went down for a while, and the data rescue project was a great way that I could identify where we could also find this open data. And so this gives a great overview. You can learn more about the data rescue project, and you can also, I really like to look at the data rescue tracker that shows the different areas and the different open data that we have been archiving and saving. And with that, if you're not sure where to start or how we can support you, depending on where your needs are. If you didn't see your discipline or your concerns addressed in this, you can always email us. At the libraries, we have this central kind of triage point of data services at utk.edu. And that goes to all of us. And sometimes we may be handing you off to some of our data partners in the Office of Research or OIT or a discipline-specific data expert like Dr. Wu, or we'll be working with you. But we're always happy to hear from you and to see what your needs are and to answer any questions that you have. So thank you, I appreciate it, and I'm open to any questions if anybody has them.
Okay, thank you very much, Brian and Jordan, for the great introduction to the open data and also some of the resources provided by UTK libraries. Keep that in mind, those resources, some of those might be specific to UTK, but many of the open access data repository are kind of accessible to the public. So if you ever have a need that you need to make your data more accessible to other groups or to the general public, then you might want to utilize some of those. And so I want to share maybe the link to the website here. Let me share my screen. 1 second. Stop video recording. If you have any questions, feel free to drop in the chat. You can also, right now, let me if you can unmute yourself, you can also ask questions. And in the next couple of minutes, I'm going to introduce some of the open data repository that you can host your data and also make it accessible through open source tools. Yeah, feel free to unmute yourself if you have any question to ask. And let me share my screen here. Where's the Zoom settings? items. All right. Can you see my screen? I'm not sure if it comes up. I might need
It
to.
looks like it's just a black screen.
Black. Okay, let me 1 second. Let me switch it. Okay. Sorry for the technical issues. What's it looks like it's frozen. Can you still hear me?
Yes, I can still hear you, but I still can't see your screen.
But yeah, my Zoom is frozen. Let me see here. Okay, let me try again. Oops. See here on screen. Okay. Can you see it now?
Yes, I can see it now.
Okay. Not sure what happened. And so as I mentioned earlier, you can go to the link here, open data. So this section has some of the resources that you can utilize. At the bottom here, have links to the UTK library resources. And also there are some other open data repositories. And earlier mentioned, Brian mentioned about the Dryad. Actually, it's at the beginning, at the top here. So these are some of the links, some of the common one. And like I said, you are welcome to utilize this. You can, depends on your need, you can use different repository or you can have multiple copies of data on all of this. And so for the rest of this workshop, I'm going to maybe just cover GitHub and Hugging Face. This can be particularly useful if you are working in the data science community and you have some machine learning project, or you just have some data, but you have a large amount of data. I mean, Zenodo and also Figshare can also be useful. The reason that I really like GitHub and Hugging Face is allows you to access the data programmatically. So if later you have develop some open source code that you can utilize some those data, you can pull the data programmatically, and then you can use that to run data analysis or data visualization. So I'm going to show you how I'm using these two resources daily. It's super useful, it's free, and you don't need to pay anything. But you can host a lot of data on there and then make your resource and data more accessible. So on the left side here, if you go to the open source project here and click Open Geospatial Solutions, so these are some of the open source projects that I create and maintain. And for example, I'm going to show you how about if you go to the data catalog. So there are a lot of open data, especially in the geospatial domain. There are a lot of open access geospatial data catalog, and from high resolution ALE imagery to satellite data. And specifically, you can look at some of the things that how you can hold some small sample data set so that you can make your resource more reproducible, that anyone can click the link, they can open your, for example, your computational Jupyter notebook, and then they can run the source code. So I'm going to open this one here just to show you open data. So this is just a GitHub repository. In the previous workshop, I already covered how to create a GitHub account and also create open data. But I would like to maybe introduce this one to you, that if you already use GitHub, this might be a great resource that you can utilize to host all kind of data. So it's just a simple, for example, GitHub repository. And right now, there's not really much going on. But one thing I really like is here on the right, you can have create a release, and then you can put all kind of data in there. And so this one is not in the GitHub source code. It's more like it's a data repository. There you can host data, you can upload data. So I can show you quickly from beginning, like how do you actually do this. And here I'm going to show you some example. For example, here some of the different releases, some of the data that I hosted. For example, global geospatial data, vector data, raster data. And so if you click the link, it will take you to either you can download the data to your computer. So basically just direct URL to the data set, or you might sometimes be able to open the data. So this allows us to stream the data to our computer, and then you can visualize this directly using some of this notebook. Maybe let me show you the other example would be using leaf map. So I can show you here. For example, this is the Python package that I created, and I provided a lot of notebooks here. I can show you some of these examples here. For example, add vector data, right? So these are some of the notebooks that you can deploy in the cloud, and you have some of these data. So the data actually come from this GitHub repository. So we are pulling the data on the fly, and then you render the data interactively. So there are a lot of examples here if you want to try some of these things out, and it's super useful because you user can go to your, for example, your website, and you don't actually have to host the data on your server because your data might be super big, your data might be small, but people can pull the data, I mean, on demand from their web browser without having to download the data. The other example would be maybe show you here, Matplotlib, and I can show you some of the here examples, right? So if you go to the website here, I can send this one in the chat so you can take a look at some of those examples. I'm going to show you, for example, 3D maybe overture buildings. Earlier, Jordan also mentioned of the OpenStreetMap, like those are all the largest open access data repository for geospatial data. But I can show you this simple example. These are the open. It's kind of similar to OpenStreetMap, but this is called Overture Maps data, and it has 3D buildings, for example, here to attribute. So we can actually render the data on demand, and this is at a global scale. So the data set itself is like several hundred gigabyte. And when we are visualizing these kind of web applications, we don't need to have the entire data catalog data set on your computer. It's pulling the data just like you're visualizing Google Map or something like that. But nice thing about this, you can have full control. So you can change the color, you can change the symbology, and you can visualize data anywhere around the globe. So this is because all the data set are at a global scale. So it's really, really nice. And this is how I utilize some of this open data out there, and you can create web applications to demonstrate some of these capabilities. The other one I can show you here. Maybe let me show you like how do you do that easily. So if you already have a GitHub account, you can just simply create a new repository, and I'm gonna show you like how easy it is to put your data in the cloud. So for example, here you can create a new repository. I can say it's open data demo. Okay, you can give a description if you want, and then you can give a README. You can choose a license, how people want to use the license. You can use choose whatever license you want. For example, Creative Commons or whatever license you like, and just create a repository. Super easy. You don't really need to know how to do code, like write code. You can just use the GitHub interface to create a repository. So once you have this one, and depends on what you want to share. If you just want to share the source code, just some small TXT files or some Python script or whatever programming language that you're using, then it's okay to just click here, this button, add file, and then you can upload files to your to this repository. So if you have some sample data on your computer, you can easily drop the data and directly to the file. So you can select your, for example, I have this country JSON, right? So this is a simple file. You can just drag and drop that to the browser and just commit changes. Then you have this one directly accessible. So now you can use this one to basically put it into your web applications or whatever you want to use, there's a button here, upper right, called the raw button. If you click this one, you will see the original data, so all the TXT data. And so this is the way that you can quickly share some small data set. If this geospatial data, GeoJSON, GitHub will automatically render that as a map. So it's very nice that you can see what's contained in your data. You can upload CSV, you can upload other types of data as well. But what I want to show you that is something that not everyone utilize, but it's super powerful, because if you have a large data set, imagine there's like 1 to 2 gigabytes, then it's usually not recommended to just upload the data to your Git repository, because the data, when you commit, is going to have to commit the changes. So if it is a large file, it's not very efficient. So in that case, you want to use a release. So the release means you can attach the file and it's not in the GitHub repository, but you basically make your data accessible. Kind of like you put your data on Google Drive or Microsoft OneDrive, but it's not basically occupying the space of the Git repository. So upper right here, if you click this resource releases, so this one allows you to create a new release. Release basically just zip all your scripts, all the files in your repository, but you can add some additional things to it. So for example, you just create a new release, and then from here you can choose a new tag. So you can just give a new one. For example, this is vector data, whatever you like. You can use just a simple name, and then from here you can generate a release automatically. If you want to have something here, that's fine. And this is where you want to utilize this one here, attach binaries by dropping them here or select them. So if you click, it should take you. It will open a dialog box on your computer and then ask you to select something. So for example here, then you can navigate your computer to select any files, or you can just drag and drop the file to your computer. So let me show you. For example, I can drop some large files to the. Let me see if I have any large file here. 1 second, let me find some sample data that I can demonstrate that you can later use this one in your source code. So for example, go to my right here. 1 second, net imagery. Oops. Net data. So for example, I have a file here. This one is like 341 megabyte. So what you can drag multiple files together. It doesn't have to use one single file. You can just drag from whatever on your computer, and you upload the file. So if you put this one into your Git repository, it's pretty big. It's going to take a while for you to commit the changes. But this one is not part of the Git history. It's just a release, basically some attachment you can think about. So look at here. Now it's uploaded 341 megabyte, and that's it. So now if you just publish, and so the file right now is accessible here. If you go to your GitHub repository, you see the file doesn't come up here, but now it's accessible here. So if you can right click, or you can, if you click your mouse, it will actually pop up a dialog. But if you want to access this one, for example, this is the link. Okay, I'm going to just copy the URL. Then you can open Notepad, or you can open a Jupyter Notebook. Then you can start doing the coding. For example, here, this is the URL. So this is the direct URL. Oops. So this is the direct URL to the file, and you can use this one in your Jupyter Notebook or any Python script if you want to. So let me quickly show you. So once I have this, you can open any notebook on your computer, or I can just simply open VS Code. Let me quickly show you how you can easily access the data that you uploaded it. So I'm going to just maybe create a new directory. So close. Oops. Or I can just go to my Jupyter Hub. I can show you how easy it is to access the data. So let me create a new notebooks here. And I can use the package that I showed you earlier, right? So this is the leaf map, and then the URL is the one that we just uploaded to GitHub, right? So this is the link to the image that we just downloaded, uploaded it, and then I can just simply create a new map, for example. Right, so this is div map, and you can see the OpenStreetMap. So what I need basically is just one line of code, add code layer, and I can just pass in the URL. Just one line of code. So take a look. So the data that I uploaded to GitHub now is accessible in my web applications, and this file is 340 megabyte, right? And you can actually publish one on the internet, and anyone can just go to the web app. They can visualize data interactively. So this is how you can make your data really accessible. That user don't have to download large amount of data. So you want to have the data in some kind of cloud native format, and upload in GitHub, generate the URL, and then put into your web application or whatever project that you're working on, and then allow people to actually visualize and interact with your data. So I would highly recommend that you utilize this one. It's super useful, and again, it's free. You don't need to pay GitHub anything. And I think for each individual, the file size limit is for each individual file is 2 gigabyte. So if it's larger than 2 gigabyte, you will subdivide it into smaller pieces. But for smaller one, I mean less than 2 gigabyte, you can just upload it and then use your web application to stream the data on demand without having to download the entire file. And so this is one way you can share your data, especially if you're working on data science project or machine learning or geospatial project. This is super nice. And you can also look at some of the sample data that I have on my GitHub repository here. Again, I'm going to show you the data set. And I put all kind of data set because I maintain those open source packages. And I always want to have some sample data that I can demonstrate in those projects, ranging from small file, only maybe a couple megabyte, to like gigabyte. So if you see some of these files here, right, these are pretty big, 1.72 gigabyte, 1 point something gigabyte. As long as your file is less than 2 gigabyte, you can upload it directly, or you can have some sample vector data set, like very small, that you can demonstrate what you are going to do. So imagine you are trying to have some journal publications, you develop something, or you produce some data, and then you want people to use it. Rather than share it as a Google Drive or maybe put on Figshare, if you put on GitHub, you can generate a direct link, and then you can use the direct link to put into your program that other people can try things out, rather than just having your things just sitting in the cloud, because people have to download the data to their computer so that they can open it. But in this way, you don't have to. So for example, here I have these two, right? These two sample files, right? Before and after. I think this is the earthquake, right? So I can easily create a map that can showcase the changes. For example, these are two files. I can quickly show you here. I open this one, and I can have maybe URL1 equal to this, okay? And then URL2 equal to the one after. And then I'm gonna come back to here. So these are the two files that I have. So how can I create map? I mean, easily to visualize the data. It'll be very simple. Just add m.split map, and then just URL1, URL2, and that should be it. It should be able to create a map, and then allows you to actually visualize the data easily. So take a look. So now I have this. I mean, just a couple lines ago, I have the data before and after. So let me zoom into this location. So this is in Libya, and you can see this is basically the flooding happening in Libya, right? And so it can be any other applications as long as like some imagery before and after, so you can quickly, I mean, showcase your data. So in that way, even people without, I mean, technical skills or not in your discipline, if you can create some applications that utilize some of this data, you'll be a lot more powerful. Just like anyone can open the browser and then can navigate to the data and then can quickly visualize changes on the Earth's surface, they will be super powerful. And you don't even need to do coding. You can actually just save this one as a map, and then you can actually open using HTML. So all you need is just m.save, right? And then you can just here just map.html. So you can generate an HTML file, and then the file you can host it somewhere in the cloud or on the website, and then just send the link to other people, then they can see it. They don't even need to know how to do coding, how to do this. And you can also provide a notebook and host it on, for example, on Google Colab, so that people can open it very easily. So this is one way of sharing data on GitHub, and the other one I recommend is using Hugging Face. So again, go to Open Data here and take a look at this one, Hugging Face. You need to sign up an account. It's free, and Hugging Face is, I mean, not just for sharing source code. It has a lot of other models, dataset, even like called the spaces. This is something that you can deploy web applications. So if you go to just Google my name, it's where to find a Hugging Face. So some of these, for example, you can not just for doing sharing your data. So if you are someone that you really want to make your resource accessible, you produce some data, you produce some algorithm. But at the end of the day, if you require everyone to download your data and then install the packages in order to use your stuff, then it's still a barrier. So if you really want to go one step further, is to create some of these web applications that you can just send the link to anybody. So I'm going to go to here. Let me send the link in the chat here. You can try some of these web applications. So I'm going to go to this one, showing how to access, for example, Maxar Open Data. So Maxar release a lot of open data. You can check out some of the links here to to some of these resources. So basically, loads of data, all geospatial data, high resolution area imagery, but you need to download the data to utilize that. So I created this web app that makes it easy for you to actually just visualize data without having to download anything. So using some like open source packages that I created, under the hood is going to pull the data from the internet and then visualize them directly. So if you want to try it out, you can take a look at this. So I'm going to show you here. For example, this is using those data, and you can go to the web app, you can click, and under the hood is going to, based on your mouse click location, it's going to pull the data from the Maxar data catalog, and then it's going to actually load it on the map. So in that way, you don't have to download the data. So this one is also the similar area that I showed you earlier, is the Libya flooding, and you can also select maybe the one outside here. Upper right, you can click, for example, split map. So in this way, you can see the changes. For example, you can compare the differences between different data layers. And this, anyone can do it, right? Because you don't need to do coding. You just open the URL. You can design whatever you want to do. You just design the algorithm and then pull the data, design the interface, and this can all be done using the, for example, the leaf map, or this one is using Solara. So this everything open source, and you can host the web app here on Hugging Face for free. So basically, think about, you don't need the hosting space, and you can have access to tons of data because it's all freely accessible. There's some other applications here. For example, we have a lot of disasters in the last couple months, and there are a lot of data. In order to do like disaster management, you need to have this kind of data, but not everyone, I mean, has the skills to process the data or even to visualize the data. So this kind of web app can be useful for the general public. They can just go there, they can click, and they can see the satellite imagery, like latest one, and then they can zoom in to see what kind of this damage that has caused in a certain area, and then you can have some of those split map to actually compare before and after the changes. So this is the so-called the Hugging Face space. I don't have time to go into detail to show you how to use everything, but you're welcome to look at the repository, and you can also look at the source code here. So if you go to the repository, every like app that I showed you earlier, for example, Libya. So this is just some of the source code behind the scene, power the web applications. It looks complicated, but it's not. You can make it just a couple lines code. You can make it really simple, just to create, for example, split map. Exactly like what I showed you earlier. So the web app, you can just have maybe 5 or 6 lines of code, and then just render the map, and then you can host it on whatever web server that you have. So this is the Hugging Face spaces. One thing that I really like is to make things accessible to anyone. Also, you have some models, also dataset. Because today we are focusing on just open data. So I'm going to show you, right, how do you upload data to Hugging Face. And similar to GitHub, you can stream the data on demand to your program. So if you click this geospatial data here, and then click the files and versions, so you can see some of these files that actually what I uploaded it is to utilize this in my open source packages, and then so that you can pull the data and you can run the program. One thing that I like is that this one also shows you, for example, if you have something on your repository, it's going to show you how many people have downloaded the data. So if you scroll down here at the bottom, right, 64,000 downloads. That means it's quite a lot. So you can basically have some statistics showing you how many people have downloaded your data. And if you want to get started, again, it's super simple. All you need to just go to the upper right corner here and then click just new dataset. Just give a name here, for example, open data demo. You can select a license. I can just maybe select MIT license, and then just make it public. New create dataset, and that's it. After that, just click files and versions here, and then upper right. So basically, this is a GitHub repository, but what I like is for the dataset, Hugging Face is like unlimited, so you can upload hundreds of gigabytes of data. Of course, don't abuse that. But if you really have a need to make your data accessible, this one is very, very good. You can upload to Hugging Face, and then you can stream the data to your program, and you can use that to do some cool stuff. I will show you later, but for now, I didn't just quickly show you upload the files. And so from here, you can just drag and drop the file. So I'm going to drop the same file that earlier I showed you on GitHub. And so this one is 341 megabyte. You can give a description if you want. Otherwise, just click commit changes. And it's super fast. Right? So within a couple seconds, your file will be available on GitHub. And then you can pull that file directly to your web applications. So for example, it's uploaded it. And you can see the file here, 358 megabyte. It's a large file, so it's GitHub Hugging Face is using this large file, to store the data. So if you click in, and on the interface here, you should be able to see this copy download link. So all you need is just click this one, or you can download, right? So in the future, if you produce any data products from your research, you can just upload here and then just send the link to anybody. But you can also showcase how to utilize the data, right? So it's create some applications. I'm just going to copy this link, and then I'm going to go back to this notebook that I created earlier. So URL equal to double quotes, right? So what I'm showing you right now is that I'm accessing this imagery from Hugging Face. So all I need to do is add code layer, and then just pass the URL. So let me run this one. And you see, it's the same mechanism. So now I have the data accessible. I can visualize this last image file, couple hundred megabyte, and can stream the data on demand without having to download the entire data set. So this is how you can put your data. It can be one, it can be multiple, you can have as many as you want. So super easy. And as you can see, I don't really use any command lines or any programming tools. All you need is just create an account and then create a repository. Then you can upload the data. So my recommendation would be, if for sharing source code, you use GitHub because people can contribute. It's the largest open repository for sharing code. But if you want to share data, if it's a small data set, I would recommend using the GitHub releases. If you have like hundreds of megabyte or gigabyte, I recommend using Hugging Face, because this is like they have a dedicated section for doing like sharing data, models or spaces. Of course, every repository still is a Git repository, but I think they optimize it and it's super fast. And also, the file size limit is much larger than GitHub. So GitHub in general, the file is larger than 2 gigabyte. It's going to be very slow, and also it takes the space of your Git repository, also the Git history. But for Hugging Face, it's not. It's like dedicated for data. If you go to the pages, people have sharing the data, and then maybe I can show you maybe DeepSeek. you can upload hundreds of gigabytes of stuff on there. For example, DeepSeek R1, I'm just going to show you like file and versions. So if you look at the file, right, each one, just a single one, you can have like 5 gigabyte, 4 gigabyte, and just this one simple repository, this one has over 400 gigabyte. So super nice, and it's free. So if you have a last, like if you have 100 gigabyte you want to share, this might be something that you can try, and then just upload the data and then share the link, and everyone can have access. So that will make your resource a lot more reproducible. And the other thing I want to show you, for example, once you have the open data, you can, for example, demonstrate some of those things in your repository. So let me show you one last thing here. For example, for this new Python package that I created called GeoAI, and if you go to the GitHub repository, on the right here, go to the homepage. So here I provide a lot of notebooks that allow people to try things out, and you can just pick any of those notebooks and you can open this one in Google Colab and you can run through the notebook examples. If you pay attention, a lot of sample data actually are hosted on Hugging Face. So when people are running the source code, they are going to pull the data from Hugging Face and they just run it interactively. So I can quickly show you this simple example. For example, I want to detect cars. So I can train a car detection model easily. So I can show you, maybe zooming a little bit here. All right. And we are running out of time, but I want to show you like this is how you can make your data and also your resource more accessible, right? So I developed a card, for example, card detection algorithm. I published a paper and I want to show people how to use it. So I developed this. I upload the data to GitHub or Hugging Face, and then I'm going to basically show you, right, a notebook that you can reproduce my results. So I'm going to have this and then download the data, and you can also visualize the data interactively. So I have some data, for example, high resolution aerial imagery, and I'm going to show you how to detect the cars. So I have some training data here. So this is the imagery, and also have this blue bounding boxes here showing you the data overlay on top of this. So this will be the data that we can use to train the model, and you can also visualize the data that we're going to test. So we're going to train the model on this imagery, also using this vector data, and then we're going to run the inference, basically the prediction on this imagery, so they can detect all the cars on this imagery. So all I need is just like run this couple lines of code to generate the data, and it's going to create the image chips. If you want to learn more, you can check out my YouTube channel to showing you step by step. But just going to quickly how you can train the model easily. So right now it's basically creating the image chips, and this is where training the train the deep learning model. And depends on the data that you have, it might take, for example, a couple minutes to train the model, or it might take hours. So it depends on the size of the data. But in this case, it's a small data set. So I'm going to train, for example, just using a couple minutes. And after that, you can just run the model to do inference. And it's super useful because you can adapt this one to do other detection on other objects, not just for cars. We're running out of time, so I'm going to stop this training, but I can quickly show you. For example, I can run this model. Maybe, let me show you here. I already have the model, so I'm going to maybe go to the outputs, models. Oh, I don't have the model here, but you can actually run the model and then you can do the detection using the model, and then you can actually use this to do the inference. So let me show you. Maybe I can show you, for example, under Hugging Face. I'm going to go to my homepage here. So for example, I already uploaded the model. So I do the training. I already pre-trained the model. So this is actually, the model is already here. So this is actually the model that I already trained. So you can download this one, right? The model, you don't have to train it from scratch. I can just download the model to my computer, and it should be super fast. You see, just 1 second. So now I have the model, and I can come here. I can just show you. I can upload the model from my computer here to this notebook. And you see, it's done. So now, once I have the model, I can just simply replace this one with my car detection model. Car Is it still uploading? Oh, it's still uploading, so it's not finished yet. But once you have the model, you can just run through that. Again, if you want to learn more, you're welcome to check out the video tutorial. So everything is on the GitHub repository here. It's super powerful. So I just show you how you can put the data on the internet and then create examples that you can showcase how to do machine learning, deep learning, AI. So I've created a series of that. Right now it's 15 tutorials. So you're welcome to try it out. And you can do all kind of cool stuff using open data, and everything is free. The source code is free, open, and the data is also free and open. And you can adapt this one to your own area, do all kind of object detection. So we are utilizing just GitHub and Hugging Face. But there are other here. If you want to like archive your source code, you can use Zenodo. That you can give a DOI, get a DOI, or on Figshare. Kind of very similar. You can upload tons of data, but these two are my favorite. So if you want to access the data programmatically in your program, this allows you to do that, and you can stream the data on demand. Okay, so we are already running out of time for a couple minutes, but I'm happy to answer any questions. If you have any questions, feel free to unmute yourself. I'm happy to share any other additional resources or anything that I know with you. You can also ask questions related to the open data and also UTK library resources. Any questions? Let me look at the Zoom chat. And thanks, Brian, for answering some of the questions on Zoom.
Of course, yeah. I think I hopefully answered all of them.
Okay, that's great. Thank you very much. Oh, there are a lot of good questions. Hugging Face, yeah, Hugging Face is yeah, it's much faster. Especially if you have a large data set. I prefer using Hugging Face than GitHub. GeoAI tutorial links. Let me see here. If you go to just the GeoAI GitHub repository, and then if you go to the URL here, and also the tutorials. This is work in progress. I guess this one I can create 100 tutorial. Right now it's only 15, but there are a lot more to come, so you can stay tuned for more updates. And I'm not sure if there's any questions from YouTube. See here. Okay, there's a question about which tool do you recommend for creating a digital book or document connected to a server like GitHub? I'm trying to create work with art connected to GitHub, but I'm still struggling. Actually, that's what we're gonna cover here in the last section. When is this one? April 21st. So in this workshop, we're gonna cover how you can use Jupyter Book to create interactive books and then host it on GitHub for free. If you go to the side menu here, open access books. This is actually the book that I wrote using Jupyter Book, and you can have the open access. For example, click this one, it will take you to the book website. So if you click the link, this is a Google Essential book that I wrote in 2023, and you can actually click here. Everything just like interactive. So it's basically you can use Markdown and Jupyter Notebook to create books. And you can have source code, and user can actually click here. They can open this one in Google Colab. They can run the code. So in that way, you can have a lot of sample codes or scripts inside that allow user to execute the source code. So for example, like this, you can allow user to import and just run it on Google Colab. So you're welcome to try out this, or you can stay tuned for the last workshop of this tutorial series. I'm going to show you how you can start from scratch, how to write a book using open source tools, and how to publish it for free. So these are all hosted on GitHub. You can also go to the GitHub repository here, and the entire book is on GitHub, and you don't really need like a publisher. Of course you can publish like traditional way, but if you really want to quickly publish something, it can be a book, or it can be just some simple notebook or some simple HTML. My GitHub has a lot of a template that allows you to create a book very easily. Again, we cover that in more details when we have that workshop. Oops. And any other questions? Interested in WebJS? Share some links to start. I provide GeoAI in Flores. Is there? Yeah, you can. Excuse me. For deploying apps on a Hugging Face, you can just go to my Hugging Face, and you can just use some of these templates. For example, Solara, Geospatial, or whatever you like. You click. Oops, some of those are not working anymore. But for example, Solara template. Then you can just up right here, clone this repository, or you can duplicate this one to your account. It's all free, open source. You're welcome to just use any of those. I might create more tutorial in the future to show how to use it, but if you want to do that, you do need to save some coding in order to deploy the apps. How do we sign up for future workshops? It's the same link. So if you go to the Open Science Workshop website and scroll down here, workshop registration, there's a link here. So if you click the link, and this is a Zoom link, so just one time you will have the same link you can join in the future for all the workshops that we have in the next couple weeks. All right, I think I've answered pretty much most of the questions. Some of the questions are very specific to GeoAI and wetland mapping. Those I will answer maybe in my other like streaming, but right now, because we are just covering open data, so I want to make sure we address those questions first. You're also welcome to go to GitHub. So if you have any specific questions about any open access or open source packages, you can go to this particular GitHub repository, and you can just open maybe an issue, or you can ask a question here, and I'm happy to answer those questions. Okay, so I think that's all for this workshop, and thank you very much, Jordan and Brian, for the introduction to open data and also the UTK resources. Again, if you have any questions, feel free to reach out to us. Also, the email is also in the chat. You can also find me on social media or on GitHub, LinkedIn, whichever you use. And we look forward to see you in the next workshop. So the next one will be, I think, next week. Let me see here. So the next one is March 31st. It's about open access funding. So if you're interested in learning some of the funding resources for doing open access publication, you're welcome to join us again, and look forward to seeing you. Thank you very much. Take care. Bye-bye.